Welcome to our channel. In today's video, we'll explore how double-edged razor blades are made and the production processes that guarantee their quality. If you enjoy this content, please give us a thumbs up and subscribe for more fascinating insights. The razor blade manufacturing process begins with high-quality stainless steel, which is rolled into thin strips. These strips are then cut into precise blade shapes using advanced laser cutting technology. The edges are honed to achieve a sharp finish, followed by coating to enhance durability and corrosion resistance. Finally, blades are packaged for distribution, ensuring consistent quality and performance. In the thermal process of razor blade manufacturing, sintering occurs at high temperatures to bond metal particles, creating a solid blade structure. This step is crucial for achieving optimal hardness and durability. After sintering, blades receive protective coatings before being tested for sharpness and treated with anti-rust oil for longevity. Blade logo oil printing involves applying a special ink mixed with oil to imprint the brand logo onto the razor blade's surface. This method ensures durability and resistance to wear during use. The printing is performed after coating but before final inspection, enhancing the product's branding while maintaining its functionality. Inspecting involves quality checks for defects and consistency. Coating applies a protective layer to the blades, enhancing durability and corrosion resistance while improving aesthetic appeal and cutting performance. The sharpness test evaluates each blade's cutting efficiency by measuring its ability to slice through various materials, ensuring optimal performance and user satisfaction. The sharpness test involves a series of precise evaluations, including cutting through standardized materials, to assess each blade's performance. This ensures they meet rigorous quality standards for effective and efficient shaving. Soaking in anti-rust oil protects blades from corrosion, extending their shelf life and ensuring reliable performance by preventing moisture damage during storage and transport. Packaging involves securely enclosing the blades in protective materials to prevent damage during transit. It includes branding elements, ensuring product visibility while maintaining hygiene and safety for consumers. Scrap processing is a critical component of the recycling industry, aimed at recovering valuable materials from waste. The process begins with the collection of scrap metal, which can include ferrous metals, like iron and steel, and non-ferrous metals, such as aluminum, copper, and brass. Once collected, the scrap is sorted based on type and quality, often using magnets and advanced sorting technologies to enhance efficiency. Following sorting, the scrap undergoes size reduction through shredding or shearing, making it easier to transport and process. The materials are then cleaned to remove impurities such as coatings and contaminants. After cleaning, the scrap is melted in a furnace, where it is transformed back into molten metal. This molten metal can then be cast into new shapes or forms, ready to be reused in manufacturing. Overall, scrap processing not only conserves natural resources and reduces landfill waste, but also minimizes energy consumption compared to primary metal production. Scrap charging is a crucial step in the steelmaking process, involving the introduction of processed scrap metal into an electric arc furnace, EAF, for melting. After sorting and shredding, the scrap is transported and loaded into the EAF, where it is subjected to high-voltage electricity, generating intense heat to melt the material. Once melted, the steel liquid is tapped from the furnace for further refining. The refining process removes impurities and adjusts the chemical composition. Following refinement, The molten steel is cast into continuous molds, forming long billets. These billets are then cut at 45 degrees using hydraulic shears, resulting in the final product ready for further processing or fabrication. Steel liquid tapping involves the controlled removal of molten steel from the electric arc furnace, EAF, after the melting process. Tapping is performed through a spout or tap hole at the bottom of the furnace. The molten steel is directed into ladles for transport to the refining station, where its composition can be adjusted and impurities removed before casting. Steel liquid refining adjusts composition and removes impurities from molten steel. Steel liquid casting involves pouring refined molten steel into continuous molds, allowing it to solidify into long, uniform billets. Billet cutting by 45-degree hydraulic shear involves using powerful hydraulic blades to precisely cut solidified billets at an angle, ensuring uniform lengths and facilitating easier handling and transportation for subsequent processing. Finished product billets are solid, uniform steel shapes for further processing. Ultra-large gear milling technology is critical for producing high-precision gears used in heavy industrial machinery, such as cement grinders, thermal power stations, and ball mills. These gears need to withstand enormous stress and operate smoothly under extreme conditions. The manufacturing process involves several steps to ensure high durability, accuracy, and efficiency. The milling of ultra-large gears begins with selecting high-quality raw materials, often alloy steel, known for its strength and ability to resist wear and tear. The gear blanks, which can weigh several tons, are first forged or cast and then heat-treated to achieve the desired hardness. Next comes the machining phase, where milling and turning are performed. Ultra-large gear milling utilizes specialized CNC, computer numerical control, milling machines, equipped with large work tables and robust spindles. These machines are capable of handling the immense size and weight of the gear blanks while maintaining precision. The gears are cut with extreme accuracy using a combination of roughing and finishing passes. The roughing phase removes the bulk of the material, while the finishing pass ensures that the teeth profiles are precisely cut according to specifications. Turning, on the other hand, is used to machine the gear's outer diameters and faces, ensuring a balanced and symmetrical design. For ultra-large gears, turning requires equally large and powerful lathes, often capable of rotating gears several meters in diameter. One of the critical challenges in this process is managing thermal expansion due to the heat generated during machining. High-precision temperature control is necessary to maintain tight tolerances, preventing deformation of the gear. Additionally, advanced inspection systems, such as coordinate measuring machines, CMMs, are employed to ensure the gears meet exacting standards for size, shape, and tooth profile. The final gears are often used in high-demand industries like cement manufacturing, where they play a crucial role in driving massive grinders, or in thermal power plants, where they support critical rotating equipment, ensuring smooth and efficient operations. The Zhongyun ZC600H is a state-of-the-art corrugated pipe production machine designed for maximum efficiency and output. Capable of reaching an impressive speed of 4 meters per minute, this machine excels in the production of high-quality ID 200mm corrugated pipes, making it ideal for industries requiring robust and durable piping solutions. One of the key features of the ZC600H is its focus on precision and quality, ensuring each pipe meets stringent industry standards. It utilizes advanced technology to maintain consistent pipe dimensions and durability, while its high-speed capability significantly enhances production efficiency. This level of performance not only reduces the ZC600H is also noted for its energy efficiency, lowering operational expenses while maintaining top-tier output. Its robust design ensures longevity and durability, making it a reliable choice for manufacturers seeking to boost productivity without compromising quality. Overall, the ZC600H stands as a powerful and efficient solution for corrugated pipe production.